I'm very honored to be here to talk to you all about a topic that I love, which is monitoring night sky brightness, data, night sky, everything that sort of touches that. Um, and we see a gorgeous picture here. I'll have a bunch of pictures from Minnesota. This is a state park up north. We are the line of 10,000 lakes, so of course had to get a nice photo of our lakes in there as well. It's not advancing. There we go. Okay. So a brief overview of what we'll be talking about today. Just to verify, the slide did advance, correct? To the
Yes,
outline slide?
yes, yeah,
Excellent,
looks
thank you.
great.
So we're going to be talking a little bit about what are we monitoring, why, so define your why, how to do it from the ground, and two different things, Globe at Night and the Starry Skies North Sky Quality Meter Network. And throughout this whole talk here, I really want to emphasize that you don't need a PhD to do this. I think all of us are aware of light pollution, obviously, and artificial light at night. But I do want to come at this from sort of a more beginner perspective so that you have the confidence and the tools to start your own. We're also going to provide the slides and links available afterwards as well. Betty Maya gave us permission to host them on our website, so no need to take screen grabs if frantically take them if you unless you want to. Okay, so what do we mean when we say monitoring night sky brightness? So let's break it down. To monitor is a verb in English. To observe and check the progress or quality of something over a period of time, and that over a period of time is important. And when we say night sky brightness, this term can encompass sky glow, naked eye limiting magnitude, other different metrics. All these different metrics are basically measuring the light pollution above us. And these are all different complementary metrics. And I really want to highlight a quote here from the Artificial Light at Night State of Science publication. There are currently no absolute metrics to characterize light pollution in wide use among researchers and practitioners. And that could potentially take that as a negative, but I take that as a positive. I mean, we do need to have some work to do, but right now that means that all these metrics that we have available to us, these are all complementary. And since there are no absolutes, though, we do really need to understand the unique situation in which we're using them and understand your why. So I want to take a brief step back here to frame where I'm coming from, my perspective, and my why. As Betty Maya said, I have a background in research and science, and I really love research as a way to understand and engage with the natural world, not just sit behind a computer and look at the natural world that way, but to get out. And this is one of the telescopes that I used during my gamma ray astrophysics days. It's about an hour and a half-ish south of Tucson, Arizona. And for scale, you can see a pickup truck here in the background. These dishes of mirrors here are about 12 meters in diameter, about 40 feet. So they're pretty big telescopes and under some of the darkest skies in the world. They're just fantastic. I also really believe in the power of volunteers, informal education, and action, which is why I was so happy to talk about action as something we can do. Because I have two little ones and three nieces, and I really, really hope I'm around for the next couple decades. So in my view, protecting the night sky is a part of protecting our planet for future generations. So just a step back of my why, but also to frame where I'm coming from in terms of my science background here. Also want to give a shout out to Starry Skies North. We're the Minnesota-based or mid-continent chapter, primarily out of Minnesota. If you don't know where Minnesota is, I would not blame you. There's a lot of countries I don't know where they are in the wonderful globe of ours. So we're right smack in the middle of the continent here between the east and the west coast. We do a lot of stuff from some of the darkest skies up at Voyageurs National Park. There's Todd Burlett, our president, and to Minneapolis, right a couple miles from the airport, very light polluted skies. There's Chris Peterson there, works for DarkSky as well. Yep, we're entirely volunteer run and a registered 501c3 organization. Okay, so why do we want to monitor light pollution in general? Couple of reasons here. First is what gets measured gets managed. If we don't know there's a problem, we can't fix it. And if we understand the light pollution quantitatively, we can manage it. Likewise, a lot of us see these amazing, inspirational, or sometimes heartbreaking stories and maps, such as this map up here of light pollution across the country, across the United States. And all of those stats and numbers, they have to come from somewhere. You need data, you need people going out and taking that data. So this is a key piece of telling that story. Monitoring implies longer term measurements. And of course, we can't go back in time to take data, but we can do what we know now and take data for future us. And I think this is really important because it provides quantifiable evidence to combat something called shifting baseline syndrome. And I think the term, I think it originates in ocean conservation. Someone correct me if I'm wrong. But here, a good tweet summarized it the best I could. Yeah, there's a really great summary here. Unless you have the time to read lots of scientific research, it's easy to not realize how much has been lost. So you accept what you see as normal. This is called shifting baseline syndrome, and it's one of the biggest obstacles to widespread and urgent action for wildlife. And I think that's true of the sky as well. Lastly, and almost most importantly, I think that monitoring light pollution is simply one more way to engage people with the night sky. And the more people we have looking up at the sky, checking out what lights are on at midnight that don't need to be on, the better. So I want to try to build some community here. It makes it a bit interactive. If you want to drop in the chat, I can't see the chat, so I'll rely on you guys to build some community and talk to each other. Drop in the chat, why are you interested in monitoring or measuring light pollution? Maybe you'll find some folks with similar motivations as you. And I'll go through a couple ideas here that I have. You might want to do this for a DarkSky Place certification. It's very necessary to get those certifications from DarkSky International. You might be interested in environmental education, getting people of all ages out into the environment and recognizing the natural resources. STEM education, perhaps you're a physical science high school teacher. You can bring some of these elements into your curriculum as well. Advocacy. If you have numbers when you go to your city councilor or whoever it is in your province or your state, sometimes that is more influential, or that can be influential and supportive of the stories that we're telling here. You can compare the night sky, not the sky guides, the night sky at different sites. I don't know how many times I've gotten a text from somebody that says, hey, the aurora are happening. Where's a really good dark sky place to go see the aurora tonight? And this is a really great way to be able to point them to and say, hey, this sky is at this park is X amount darker or brighter than the sky at this park. So it's a really great way to compare different sites. It's also great for astrotourism marketing. If you're a hotel that wants to draw people in for your stargazing, you can say, you know, we are darker than this other site, or hey, we've put these initiatives in place and now we are darker than we were last year, right? That monitoring piece, and that's really powerful. And most importantly, we're really looking for evolution in light pollution here when we monitor. That can be either saying, hey, something changed and now the sky is brighter, why? Or it could be, hey, something changed and the sky is darker, great. We're doing something right, let's build on that. You can also look for changes in color. I won't talk a lot about that today, but it certainly is possible. Okay, so this is a lot of words, but I'm going to walk through it here. This is something, a sort of framework and some questions that I hope are useful when you want to translate your why into an action plan. So a couple questions you want to ask yourself over here with some examples. So ignore the two examples for now. So once you know why you want to monitor light pollution, you need to then ask yourself, how often do you need to measure it? Do you need measurements every 2 minutes for 5 years? Do you need it a couple times a year? What tools can accomplish this? And this is really, you know, what tools can accomplish this? Think big. Maybe you need the Hubble Space Telescope. Maybe you don't. But then get into what tools do you have access to? Well, I don't have access to the Hubble Space Telescope, but maybe I have an app or something. Who is your audience? Who do you want to get involved in this project? who do you want to present your results to? Do you want to present them to a city councilor? Do you want to present them to preschoolers? Those are two very different audiences here. And then last, how are you going to interpret your results? So a number is just a number, and you really need some context to build a story around that. So 2 examples of a nature center here, and these are some things that Starry Skies North has actually done. So this comes from our experience. So 2 examples, yeah, different nature centers, but both nature centers here. Maybe you want to develop some nighttime educational programming. You only need to measure every few months. It's not very strict how often you measure it, so that's fine. What tools accomplish this? Globe at Night is a great one. It's not an app, but it's a website, right? So you need to have access to some sort of device. The Loss of the Night is a free app that's great, as well as DarkSky Meter app, which is $2, which is far cheaper than some of the other meters. What tools do you have access to? An app, great. That would rule out a lot of other different tools that could accomplish the same thing. Who's your audience? Ages 12 plus. So maybe you go out on a moon hike and you want to go out and take observations. That is a really, really great way to access that for that audience of ages 12 and up. It's a pretty broad audience as well. And then how are you going to interpret your results? Maybe you come inside after that night hike and you provide context on a whiteboard. And what you can do is then take those data, take those measurements that you took from a last month's night hike and show them to this month's night hike. And then you can compare and discuss that way. That's one example of how you might want to monitor. Say you are a nature center and you are pursuing an urban night sky place designation, and you already have an interpretive exhibit on light pollution, so you want to incorporate it there. I will say that DarkSky International, I still slip, has all of these, the certification designation guidelines online. So I've pulled it directly from this here. Perhaps you want to measure a couple times a year. I think you only need one for the UNSP designation. But they do say in the guidelines you need to use a dark sky approved night sky brightness measuring equipment. So that is what tool has to accomplish that goal. What do you have access to? Maybe you borrowed a unihedron sky quality meter from your local DarkSky chapter. Who is your audience? DarkSky International is your audience for the application, of course. But you also might want to consider the visitors to the Nature Center. And so when you interpret your results, you have the application, of course, which is a formal document, but maybe you want to have a placard in your visitor center that's updated, say, once a year for visitors. And so if you take measurements a couple times a year, then you can update that placard once a year when you do that process. So yeah, these are just a couple of examples, and I really like this this process of how you come up with an action plan. This is, if you're an engineer or scientist, is very similar to designing a research study or defining your engineering requirements as well, but more general. Okay, so how today I wanted to discuss a lot how to measure night sky brightness from the ground and why. So there's a lot of different tools out there for that are remote sensing. So satellites, drones, things like that. I'm not going to be talking a lot about that today, but those are incredibly important tools and a complementary part of the story here. So measurements from the ground here tell us how humans and wildlife experience light pollution, right? So if you're a satellite, you are reliant on capturing the light that comes up into outer space. And of course, there's some modeling applied to predict what that means for the light on the ground here. But we do use ground measurements, of course, to normalize those. So we have light that reflects off of atmospheric molecules, aerosols, clouds, etc., that contributes to our sky glow. And that's what we're measuring from the ground. Okay. So we are cruising right along, and I want to talk a bit about how to measure light pollution in 3 specific ways here. I also want to mention that I built in a bunch of time for questions, so please, like always, feel free to put them in the, I don't know if we have the Q&A set up or the chat, but I know Betty Maya and
yeah.
Okay, you guys always do a really good job of that, so um, not concerned. All right, so 3 different ways of measuring light pollution that I'm going to discuss a little bit about tonight or today. First is globe at night. And if you have not heard of globe at night, welcome to your new favorite hobby. Only partly kidding. You can participate in globe at night once or many times. It's really great because it requires no experience or equipment, just your eyes. However, you can use a sky quality meter, and I'll talk a bit about that in your globe at night observations. And that brings me to these handheld sky quality meters, or SQM. And these are devices about the size of maybe a deck of cards, your cell phone. And these take a single quantitative measure of sky brightness. You point them at the sky and you press the button, and it takes a measurement. And third, I'm going to be talking about a network of sky quality meters that are mounted and logging, which means they log the data in the device itself. And these take measurements every few minutes. And so instead of having to sit there and hit the button repeatedly, it just automatically takes measurements. Okay, so Globe at Night is the International Citizen Science Project. There are so many different talks on this from DarkSky, as well as International DarkSky Week, advocate meetings, lots of that. So I'm not going to talk a lot about how to participate generally in that, but as an overview, it's very simple, quite honestly, is you look at the night sky wherever you are and report how many stars you can see. The more stars you can see, the darker the skies. And you submit that data to Globe at Night, and they handle all of the complexities of the data analysis and making meaning out of that. In 2023, there were 22,000 data points uploaded from across the world, which is amazing. There are observing campaigns to go out and submit these observations every month. The current campaign is going on right now and ends on August 4th. So you have a few more days if you want to go get out still. And when it comes to monitoring, when we talk about long-term data, they actually have data that's publicly available back to 2006. And I'm going to talk a bit about how to access that because I think that's really powerful. Because if you're coming to this and you're brand new in the year 2020, 2024, obviously you can't go back in time, but they have all the data publicly available. So this is just a snapshot of the map from 2023 observations, Minnesota, of course, and our surrounding states. And this map is interactive. It's really great. Each dot represents a different observation here. And I'm very happy they had this feature disabled for several months, but now it's back. You can actually download all the data as a CSV right here. So what you see in this map can be downloaded as a CSV. And if you've never used a CSV stands for comma separated variable. It's essentially a text file. You can open it with lots of different applications. I'll show an example of one, but it's very, very flexible and makes it very easy to look at data. And I always like to mention that Globe at Night is real science. You're not just, sending this off to the abyss. People who write reports on these, and there was a really great report. I say great because the science was great. The results were not so great. In January 2023, reporting rapid reductions in the visibility of stars over this time period. And the report itself you can read definitely, but one of the big takeaways for me is this conclusion 2 here. The use of naked eye observations by citizen scientists provides complementary information to the satellite data set. So it's people who go out and people who may take one observation. They might take one every month. They might take a bunch in 1 month. But it really contributes, even if you're not the one that's going out and taking those monitoring observations every single month, the data are there and you can participate in that, and it contributes to this long-term monitoring. All right, so a sky quality meter here. A lot of people, many people have heard of these sky quality meters or may have even used one. And I think these are really, really great devices. They're very accessible in terms of how to take the data. You don't need any fancy equipment, you just need the device itself. They do get pricey, so that's one way that it's not as accessible. A couple years ago, DarkSky had a great application process to get a device for advocates and chapters, I believe. I don't think that's going on anymore. folks on the call can correct me if I'm wrong. I hope I'm wrong. But that means that a lot of people out there have access to these, so you can borrow them from other advocates, local chapters, etc. So these devices are a quantitative measure of the night sky brightness. You point it up at the sky and you press the button and it gives you a number, which represents the sky glow above you. The unihedron one here shown on the top, it gives you this number in magnitudes per arc second squared. And astronomers, we like seemingly goofy units for things. Magnitudes, you might hear magnitude talked about it as how bright a star is in the sky. The higher the number, the dimmer it is, which seems backwards sometimes. But it also means the higher the number, the darker it is. So I like thinking about it like that. These are about $155 last time I checked, directly from the manufacturer. And then there's this one down here, the Opal light meter, which last I checked, this one was about $50. And it's Lightmaster 3. These are the two devices that DarkSky recommends. And this is a really nice one because I think it also has the color, and you connect it to via Bluetooth to an app on your phone to take the measurements. So what can you do with these measurements and how do you actually monitor with them is the next logical questions here. You can contribute them to Globe at Night, partner with a local DarkSky chapter advocate, or start your own database of these measurements. And when I say database, that can be as simple as a spreadsheet. We don't need anything terribly fancy if you don't have access to it. It's great. So to monitor, again, we're thinking longer term measurements. Some tips for that is you want to choose consistent locations and times. So if you want to build a set of these measurements over a year, 2 years, or even just simply over a week or a month, you want to choose a consistent location. You want to think ahead about your seasons. Here in Minnesota, we have winter, and this past winter was, I think, one of the least snowy on record. It was very, very mild. It was kind of nice, to be honest. But the winter before, we broke all these records for precipitation, and we'd have these winter storms and it wasn't even any news anymore. We were just so used to it. But that meant that I did not want to be tramping out into the middle of the forest in freshly fallen snow once a week to go and take a measurement at midnight, right? So think ahead about these seasons. You want to make it very, very easy on yourself to be consistent in these measurements. So if you want to go out and tramp out in the middle of the forest, that's great. I think for me, it's much easier to walk down the street to my local park. And that local park has a big soccer field, so it's pretty open. So I can stand in the middle of the soccer field and point my meter up and walk 2 minutes home, right? I want to make it much easier on myself to be consistent. Okay, so how to take and some tips on how to take these handheld sky quality meter measurements. So if you decide you want to do some monitoring or you just want to do it, once or twice, here are a couple steps here. So first, of course, purchase or somehow obtain a sky quality meter. Borrowing one is really great. A lot of DarkSky chapters, like I said, have them in delegates. Some astronomy departments and clubs. So the Minnesota Astronomical Society, I know we work with them, and they have some. Schools and libraries potentially have some to check out. I think there's a group out of Montana. They have a really great kit, I think, that they pass around, and they're building up a database and network as well. So check out some of those resources that are local to you before investing in a sky quality meter if that's not something you want to do. You want to print out a data sheet. And here at the bottom here, DarkSky, I'm never going to reinvent the wheel here because DarkSky provides two fantastic, great spreadsheets to log your data. So print them out and bring with you, especially if you're somewhere remote where you might not have cell phone access. Of course, be cautious about using your device or your screen if you're taking data and recording things on your phone in order to protect your night vision. So when you take these, you want to be sure you're going out during astronomical darkness. And there are lots of tools you can look up when astronomical darkness is at your location. But I think a really good rule of thumb is about an hour after sunset. And also an hour before sunrise then too. Find a location with a clear view of the sky. So some of these, I think it's about 15 to 20 degrees is all they really need. And however, you want to make sure you're completely clear of any buildings or tall trees. Like I said, a soccer field or on top of a hill is really great. Depending on where you live, you could even go out in the middle of a street, something like that. Make sure you have a clear view of the sky and point the device at the sky and take a measurement. You're going to want to take 6 total. We always take out or toss out the first measurement, and the next 5, record all of those, and those are your 5 measurements. And eventually you'll be taking the average of them, but I really like to record all 5 of them so that you have a record of them. Again, you can't go back in time, so be kind to your future self and record all the information that you can. You also want to note the location, the time, the weather. Latitude and longitude are really great. Obviously, if you don't have access to a GPS, that's a little bit harder. However, you can use Google Maps to go and look up your latitude and longitude. I think that has been a great hack that I discovered, is just drop a pin wherever you are and you can get your lat and lon that way. Again, the more information, the better. Make it easy on your future self and make it easy on yourself to be consistent. Okay, so as I mentioned at the very beginning, numbers are obviously just numbers. We humans, we have to put these in context and we put meaning to them. There was a really great, I honestly stumbled onto this by accident about 1.5 years ago at the Bell Museum, which is the natural history museum run by the University of Minnesota here. There's a great exhibit by Mike Shaw, and he went around the state and he took sky quality meter readings here, you can see, at all these different locations to compare. Right? And that's what we're really getting at here, is being able to compare them and put them in context. So these numbers that you'll get will range anywhere from, oh gosh, like 10 to 23. Maybe not 10, but you can see here at some of these darker sites here are the black and the dark blue here. So you can see a number of 21.49 here. And then all the way down to 17.0 at the state capitol, so downtown St. Paul. So remember, the higher the number from the sky quality meter, the darker it is. And that means, of course, the lower the number, the brighter it is. And of course, downtown St. Paul, Stone Arch Bridge in Minneapolis is also downtown. These are more suburban areas, going to rural areas, and then some pretty dark skies here. And you can see those line up with our numbers as well. And putting them on a map is a fantastic way to visualize for people as well. So again, what do these numbers mean? This is something that, again, is a lot of text, but I do like to print this out and bring it to events sometimes, because it's a really great way of putting these meter measurements in context here. And so I created this from a really great article in this Sky and Telescope magazine from many years ago. It's been recreated in many iterations, but this column here is our approximate sky quality meter number. So you have that device, and the number it gives you will be in this column here, and you can relate it to the Bortle class and then the title, so the category of the sky, whether it's a city sky, suburban, rural. And more importantly, I think when you're communicating this to people and to yourself, is understanding, what does that mean? What does a Bortle class 4 look like? It means that the surroundings are clearly visible, even at a distance. Milky Way is straight above is still impressive. And so it gives you sort of a good feeling about what you might actually see here. So to be able to relate the numbers to the class, to the title, to what that implies for what you're seeing and your lived experience might be when you're under those skies. Okay, and so I'm not sure if everyone knows this, but I think everybody who participates in Globe at Night should know this, is that you can contribute a sky quality meter reading to Globe at Night. So there's a step here, and step 3, it's optional, of course, but you can submit it. And once you download that CSV file, that means that all those observations from other people are also public. And that means that I can go out in my front yard or my state or wherever and take a measurement, and I can't, like I said, I can't go back in time to compare and to monitor, see if that number is higher or lower than what it used to be, but I can go into the public data here, download it, and be able to compare. So as an example here, I grabbed one from Australia, and you see here, these are what the data look like if you grab it from the Globe at Night site. This is a CSV file, comma separated variables, so it's simply a text file, excuse me, with columns. I opened this in Excel. You could use, whichever program you like best. So these folks in Australia took a couple measurements. So it's about 21 point, if I just eyeball, maybe, I don't know, call it 21.6 on average here out in country Australia. And that was last December. So they could go out this December, could be a whole different set of people. And now they'd have these numbers to refer to. And that's, of course, considered monitoring because we're doing long-term measurements here. So 21.6, let's go back to our table here. 21.6 is right between portal class 2 and 3 roughly. So that was a pretty dark sky or dark site that they were at, that they were taking those measurements at. So yeah, I think that's very, very cool that Globe at Night makes this public for anybody to access. Word of caution, I'm not sure exactly how much quality control has been done. I did see some unrealistic values like 100 or 6. So use it your own discretion, of course, but it can be a very powerful tool and resource for you. Okay, I want to do a poll here real quick. And Betty Maya set this up for me, and I realized last night that I did not include an option for not yet when I gave her the poll options. So I think I can't see. Oh, yep, there's the poll. Great. So let us, instead of the option for multiple, let's say that actually is not yet, meaning you've never done any night sky monitoring. So I've used Globe at Night, a sky quality meter, a drone or other imaging, something else, or not yet. And how about we just do 30 more seconds here to submit that?
All right, they're coming in. We got 5 more seconds till 1 minute.
Awesome, thank you.
Okay, I'm gonna go ahead and end it, and I will share the results. Can you guys see those?
Yeah, thank you. Can you all see the results as well?
I think they should be able to, yeah.
Okay, great.
Yeah.
Excellent. So yeah, 36% Globe at Night, 64 sky quality meter, less for drone and other, and 21% for not yet. Great. So huge wide variety. That's awesome. All right, thanks for participating, everyone. All right, so then now, how are we doing on time here? Great. Lastly, I wanted to talk about the mounted sky quality meter network that Starry Skies North has been developing the past couple years or so. So this is actually based on a project that Oregon has underway. And our goal is to develop and install a network of logging sky quality meters to quantify the sky glow across Minnesota, our surrounding region, and provide the data, analysis tools, and interpretation publicly. So Unihedron is the manufacturer of the sky quality meter here shown here. And it's logging. So this looks different than the other handheld one. It has no screen or any button here because it just continuously takes data. It's battery powered. This one is battery powered. And they sell these housings along with it. So it's a PVC pipe with a hole here, and then you can sort of see it. There's a little bit of a foam here, but it keeps the device upright and positioned properly inside of the housing here. These can then be mounted in a variety of different ways. I'll show you a couple examples. This one is in the backyard of Todd Roulette, Starry Skies North's president. And you can see it's mounted to one of those U-sticks that you can get at like Home Depot, Lowe's, a basic garden or a hardware store. here in his backyard taking data. This is entirely volunteer run, which has been a fun learning experience. Everybody comes with our different backgrounds and different experiences, which I'll also talk about. But yeah, we've got a lot of great volunteers who have installed these and are taking data and are going to help analyze the data. So we are working with local partners, and the partners are ones that will host the meters. So one of our partners, or actually all of them right here, the locations are listed out. Some of them are residences. So we have one at Todd's residence, Mark Job's residence, mine. We have some nature centers and camps. We're also working with the Minnesota Astronomical Society, as well as their observatories to host them, and the University of Minnesota Astronomy Department has one on the roof of their building as well. So here you see Wood Lake Nature Center. It's very open here. They actually just got a huge grant to build a new building, so they have not installed their meter yet. There's going to be a lot of construction, but Wood Lake was one of the first people who was on board with this, so I want to always give them a shout out. One thing that has been a huge learning experience for us is to understand our partners' interests and motivation. One thing that we kept hearing from them is documentation, and that's been desired. So where to purchase the device, how to install it, how to take the data, how to upload the data, and we're working on developing that right now. We have PDFs in the works for each of those different steps and hoping to ensure that they become their best versions by getting feedback from everybody. So a couple of them examples of the mounted sky quality meters here. This is the Job residence, Mark Job. He's involved in Minnesota Astronomical Society. He also gave a really great talk at International Dark Sky Week this year as well. So one thing I want to highlight is the various ways that they can be mounted. So this is all the same device. It comes with this housing and the metal mounting hardware here. But the way Mark has it mounted is on a PVC pipe here on to the side of his building. And he also has an all-sky camera. The astronomer that he is, of course, he has an all-sky camera. Also want to shout out the great shielded light fixture he has there too. This is Todd's. He has it mounted, like I mentioned, on a one of those U-sticks, U-poles from a hardware store. You also see here that, of course, we're in Minnesota, which means it snows, and we get snow and refreeze and build up on the top of the devices as well. And third here, this is the University of Minnesota Astronomy Department, which is in downtown Minneapolis, most light polluted skies in the state. Of course, I should mention that Maple Grove is suburbs of Minneapolis, and Buffalo is also suburbs a bit farther out. But you see here, this one, they actually decided to purchase an Ethernet connected one, so it does not log the data on the device. It logs the data to a computer inside, and it's connected via Ethernet. We learned that might not have been worth the hassle that it was. They had to get their IT department involved, and it only logs the data to one specific computer, and so it requires a person to go into it. So again, just a sort of word of warning that you always want to think ahead. How are you going to get the data out of these devices? It's not always the seemingly easier solution is maybe not always as easy, but you can see their observatory dome in the background there. It's really cool. Okay, so once you have these meters up, you can download the data using the Unity Drawn software that it comes with. And I'm not going to talk a bit about that, but I'm going to talk about how we do our data and code management. So we are using GitHub, and if you have not ever heard of GitHub, you are certainly not alone. This is a platform to create, store, manage, and share code specifically. It can store data. Purists will say, no, you don't ever want to store your data in Git like this. But we are using it to store our data for now. There are other probably better tools, but for now, it's really useful to have one single account, one place where people can upload the data and it can be accessed programmatically. I know things like Google Drive, Dropbox, other things like that. We really want to be able to access our data programmatically, and this is a way to do that. GitHub is free to sign up, so anybody can make an account. and they have a lot of tutorials. It has a lingo and a language, but they do have a lot of tutorials. There's lots of stuff on YouTube about how to use it. However, a private repository, so a repository is just a simply like a big bucket of your code and your data. To get a private bucket, you need a premium account. And when you're in the United States and you get a 501c, you are a 501c3 certified organization, you get a premium account for free, which is great. One of those benefits of being a 501c3 that's not necessarily tax related, but that has been great. So all of our data are currently public, and code is currently public. That's not true. It's all currently private. We're trying hard to balance privacy of our participants with open access of the results, and that's sort of something we're working on managing. You also, when you decide which different tools to use, again, Dropbox, Google Drive, those are also really great tools, but you need to think about your audience and the people who are going to be using these tools. I told someone I would just push it from the command line. And if you're familiar with this, something like this, that makes perfect sense. If you've never heard of this, that's not going to make any sense to you. That's just gibberish. And I said that to somebody who was a very accomplished engineer, somebody who is obviously incredibly competent, but he said, I have no idea what you're saying. So a reminder that even though everybody is competent, they always bring their own experiences and knowledges and and knowledge background. And so you really want to keep that in mind when you choose your tool and when you're teaching people to use the tools that you have chosen. All right. Some sample data from this here. We are doing our data analysis in Python. And I'm not going to talk a bit about this plot. I have a better one on the next slide here, but we have applied some filtering. So we obviously take out all the times during the day. We take out all the times when the moon is above this 10 degrees below the horizon. And we want realistic values. And then a really great thing that comes out of the Unihedron software that comes with the device is called this residual standard error. And it's a quantification of how jagged the data are. So I want to talk about this one instead. So I'm going to walk you through this here. These are 3 separate nights of data from the Berlout residence, and Todd gave me permission to show this data publicly. On the bottom here, you have time. So this is 1 day, 2nd day, 3rd day. And here you have that magnitudes per square arc second. So the larger the number, the darker it is. And you can see here that obviously during the day is when it's 0. It's incredibly bright, sun is out. And then it gets darker, 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 darker. And then it's pretty well flat and dark overnight. This night here is pretty cloudy. So it's jagged. And you can see that that it gets a little bit brighter when the clouds come through. Yeah. And likewise here, it's less cloudy in this day than this day. Have clouds maybe here and here. But yeah, this is what the data, these blue points and orange points are what the data look like when you visualize them here. So instead of a single point measurement here, you're taking a point measurement every couple of minutes. So you have a view of what the sky brightness is over the whole night, which is very, very powerful. It means that you can filter out bad data. So I've applied a bunch of filtering here to identify our good data, which is in orange. So this data here, this day had no good data, no orange dots here, because it's completely cloudy. And so it's very useful to have continuous data like this because it did not require anybody to go out and take that data that was just going to be thrown out anyway, right? It's kind of heartbreaking to not be able to use the data that you painstakingly went out to take. So Todd sat in his house, probably, answering emails or doing the great things Todd does, and the meter was in the backyard taking all the data and doing all the work for him, which is really, really a powerful reason to have these continuous data sets. So his meter has been out since 2022 now, and I have data through June of this year. So, oh gosh, yeah, it's August 1st, so about a month ago. And if you put all of those nights on top of each other, this is what you get. So I'll give you a minute to digest this here as I walk you through it. This axis here shows the time of night. So on this side, it's sunset, goes to this side is sunrise. And then we have that same magnitudes per square arc second where this side up here is darker and down here is brighter. And each one of these data points is one of those good filtered data, so good quality. And what you can see here is that, yeah, throughout the night, it's about 19, on average, 19.12 magnitudes per arc second, excuse me, magnitudes per square arc second. And yeah, so you can see here, really interesting, it gets darker, slightly darker throughout the night. You can see these data points sort of rise as more lights get turned off because they're not in use in the area. That's one reason. Could be other reasons as well. You do see some outliers here, and I really want to throw out a word of caution that we're not going to ever remove data by hand. We want to have a reason for removing that and a prescription of those filter rules ahead of time. So if you say, oh, this is a bad day here, these data are bad because it snowed. You can't just remove that one and say, oh, we're going to remove that one because it snowed. You have to say, okay, we're going to remove that one because it snowed, I don't know, 2 feet. You're going to also have to look back through your data and say, okay, we have to remove every day where it snowed 2 feet. So you need to think that through and not be cherry picking data, of course. This number also means that in Todd's background, it is Bordeaux Class 6, which tracks as a bright suburban sky. I actually grew up in this same suburb, and yeah, it's very interesting because we used to be able to see the northern lights like laying in the front yard. And I remember it was so much darker. And so it'd be very interesting to compare to numbers if we had them back when I was in middle school and elementary school to see how much darker it was. So a couple of lessons here. I know I did not go into super technical detail, but I am always happy to answer questions via email or here or Slack about some of the more technical details that were maybe not covered here. When talking with folks, big lesson, make no assumptions, over communicate, making sure you acknowledge everybody is competent and everybody has different knowledge backgrounds that they're bringing to the table. This has been a really, really great way to build new partnerships as well as learn from our existing ones. We really, really have been welcoming feedback. That's how we know that they really want to sort of have their hand held in terms of how do we install it, how do we take the data, where do we find the data, that sort of thing. And it's been powerful. We have no lack of ideas. A lot of people have been coming to say, oh, what if you did this? What if you did that? And executing those ideas is really where learning happens. So like I mentioned with the internet connected meter, it sounds great, but it actually, we learned that it might have been more hassle than it was worth in that specific case. In other cases, it might have been great. We have a couple next steps here. Primary one is to publish our first report and streamline our process. We're working on getting open access Python tools and to understand how these meters perform long term. And long term, I'd love to create an interactive map so that when folks want to go out and stargaze or look for northern lights, they can go to our website, pull up the map of actual real data that our chapter has taken and say, oh, this part here, great chance, great dark skies, I'm gonna go check out the northern lights there. And it gets more people involved in appreciating the night sky. All right, so this is my conclusion slide here. Got about 5 minutes. Some takeaways I hope that you got. Monitoring night sky brightness is important, and in my humble opinion, it's a fun action that you can take as a advocate. It's really easy to integrate it into educational programming that's existing too. There's lots of tools for you to use. Make sure you use the right tool for the job. That's really my main takeaway here that I hope you get out of it is use the right tool for the right job, for the job. Make consistency easy in yourself. Again, think about future you, what would future you want to do? But also don't be afraid to just dive into a project. We don't want to get in that analysis paralysis. There are lots of people out there who are willing to help. I'm here talking about this, but there are lots of people out there who are more knowledgeable than I am, and knowledgeable in different ways. Starry Skies North is here to help, and the goat, obviously. I had to throw in a little Olympics reference there. The goat is DarkSky. They have a lot of great resources. I've been very impressed with all the stuff that they have available for free publicly on their website. So thank you very much. Happy to answer questions.
Thank you so much, Caitlin. You are too sweet. That made me laugh a lot. So thank you for the shout out to Dark Sky. And we really are only the GOAT because of all the people making up our Dark Sky network, which includes Starry Skies North. And you guys have been a shining star in the night sky blanket of chapters all over the world that really help point the way and are leading the effort for others. So thank you for being here and thank you for sharing all of your knowledge with us today. And there are some questions, so I will go ahead and start passing those along to you. Let's see, what was the first one here? Stephen asks, how sensitive are SQMs to blue light?
Ah, they That's a good question. They're not as sensitive as we need them to be right now because we're seeing more and more and more blue light. But I think they're more sensitive than um, oh, the screen changed. Yeah, they're more sensitive than I think some of the satellites are in terms of what the wavelength coverage. I think that the Apple one I mentioned, with the little round circle that you connect to your phone, that one I believe gives you actual information about the color. So if you're really interested in color, I would go for one of those.
Awesome. And so that there was kind of a question about that as well. That Opal or Opal, I'm not exactly sure how to pronounce it. That light meter is for directly measuring light sources, right? And not necessarily
Yes,
for
yes.
measuring the night sky brightness as
Yeah.
well. Um,
Yeah, we have done it to measure the night sky as long as there's no bright sources around. Um, yeah,
Interesting. Yeah,
caveat.
I've used it
Yeah,
to measure like specific light sources to get the
that too, yeah.
CCD. But so you've actually used it to measure the night sky?
Because it has a larger field of view. Um,
Okay.
so like the handheld one, I need to grab mine before the next presentation. The handheld one, the field of view is so much smaller, and so you get a view just straight up. But the Apple one is a larger field of view, I believe, and so it will. Yeah, you're right. You put it under a light, and it will capture it. But yeah, I apologize. I don't know completely. I'll have to get back to you. That's a good point.
It's all right. Yeah, thank you. Okay, let's see. What was the next question? Stephanie says, I live near Saguaro National Park East. Nice, Tucson represent. And have a flat roof I can use to take readings off of. Would that work? So
Abs
maybe, yeah, for that, if you want to just talk about kind of like where people can do this
oh,
generally, uh,
yeah.
yeah, that'd be great.
Yeah, good question. You can do it wherever you're outside, honestly, and wherever you have a good view of the sky. So when I say 15 degrees, that's sometimes hard to visualize, but the astronomer in me is if you put your fist out like this and you stick it up, it's roughly that field of view that you can see. I know you can't see on my screen, but if this was my arms straight up, that's about, or even two to be cautious about the field of view that you see. If you do this and you stick it straight up in the sky, and as long as your hands aren't covering any buildings or trees, then you're good. Yeah, a roof is a really great place. Yeah, like I said, soccer field. I go out in the middle of my driveway. As long as you're outside and you don't have um, a lot of lights right around you. So I would, of course, if you're have control over the building you're nearby, I would turn off all the lights inside there. Um, you might not have control over that, but yeah.
Awesome. Uh, yeah, a lot of people are commenting that they're going to get out and start monitoring. So this has been a super what's the word? Inspiring
Oh,
presentation
good.
for people. So awesome. Thank you for that. Mike Wiesner has a question about the data cataloging battery powered SQM. He works for Oracle State Park and they are Mac based. Does the
Uh,
software included with the SQM support on the Mac? If not, is the data file just a CSV or a tab delimited file that can be understood by a non-technical human? They are currently just using a handheld SQM, so that's why he's asking.
that is a good question. I think one of our members uses a Mac. Yeah, yeah. Todd uses a Mac and it's fine. I have Windows, so I have not personally done it, but yeah, I'm pretty sure it's Mac operated or supported by Mac. You do need the Unihedron software to take the data from the device. So you plug it in via a USB, and I know there's of course conversions for Macs. And then the device or the software takes the data from the device, and then it does some calculations. But that first step of the raw data that can be exported into a text, yeah, some delimited file. Yep.
Cool. Yeah, so I guess just in general, like I'm a non-technical human, except for when it comes to cameras. I don't know. Even then, I struggle. But like, what would you say is like a good first step or first resource or something for somebody who's been doing SQM just by hand, right? Or doing globe at night, but they want to like look into having something taking measurements while they're inside cooking dinner, right? That sounds nice. Like, what's the first step for me or others who kind of need a little support and don't have this engineering or science background?
Honestly, the Unihedron mounted ones, they have really great tutorials and resources. I would start reading through their webpage or reach out to someone like me or the folks from Oregon or Montana folks too, and have us sit down and we can fill in some gaps as you go. But I've been really impressed, honestly, with Unihedron's website. It might not look like the most, fancy,
Definitely
sexy,
has a 90s
I
vibe to it.
yes, it does.
Yeah.
But the information, the content is top notch and very, very easy to understand in my opinion. So I would
Cool.
start there.
That's great to hear. Yeah, I know the Oregon folks have done presentations for us before, and we have those available on our YouTube. And you guys are on Slack as well, right? If people want
Yep.
to get a hold of you. And
Feel free to
I
put my
know,
email in there too.
yes, I will. Can I put, is it okay if I put your email into the chat?
Yes, definitely.
It's on your link doc. I tried to keep up with the links, so Caitlin did a great job of providing us links beforehand and making it really easy to share the links out. We can also just kind of make that into a PDF that we can share out with the recording as
Sure.
well. If you
Cool.
miss any of the links or don't want to save the chat, we have a little document that Caitlin put together so kindly for us to share out with a bunch of resources to help you with this. So let's see, there were some other questions, and I know I do want to be mindful of your time, Caitlin.
The only thing I have going on is to watch the women's gymnastics.
Oh, awesome. Well, that is very important. So let me know when you need to head out. But Jim asks, if taking handheld SQM readings, should you avoid cloudy nights, and is any amount of cloud acceptable?
Oh, excellent question. Some amount of clouds is acceptable. I would avoid the nights where it's completely socked in. You can't see any sort of skies, any sort of stars. And I would avoid them when they're directly overhead. So if they're only, on the horizon or so, that's probably fine. Um, but that could be also really interesting if you went out the next night and compared and see how much of an impact the clouds had. Even like
Yeah.
the thin ones might have an impact. But yeah, avoid the socked-in nights for sure.
And oh shoot, what was I gonna say? I totally just forgot. Oh, I was gonna say the Milky Way can even add, right? Do you do anything when you're measuring and the Milky Way is bright and right above head? I mean, maybe you guys can't necessarily see where you have those, but like for people who are in super dark sky areas, is there anything that they should take note of while the bright Milky Way is at the zenith?
Oh, yes, excellent question. I would take a couple, like if you can see the Milky Way, A, I'm jealous. B, I would try, if possible, to take a couple throughout the night and take really good notes of when you took those observations, because there are some programs online where you can determine like how much or where the Milky Way was at those times. And so um, you can sort of correct for that, or at least understand why the measurements might be different if it's because of the Milky Way.
Yeah. I know Derek Wallentinson, I don't know if you're familiar with him. He's a park ranger in a lot of different parks. Has, said that he almost like if they're measuring in the Milky Ways right above head, he adds like a 0.1 or a 0.2 to the which I don't know how kosher that is, but
Like
that's
I
what
said,
I
I'd be jealous. A
heard.
problem I'd like to have.
Um, Cool. And then I thought I saw a question here that was kind of talking about should the 5 readings of SQM be taken facing different cardinal directions? Do you want to talk about the process of like where exactly
Oh
you
yeah.
point the meter?
Yeah, you just want to point it straight up. Yep, vertical. You could, I guess, rotate it. Can pretend my phone here, right? Because it's like a sort of a rectangular prism, right? So you could rotate it to get different readings, but you're looking to capture the statistical uncertainty and the statistical variation when you're taking multiple measurements. And so that's why you want to take at least 5. I would go for 10 personally, but I know DarkSky recommends 5. Like this, sure, but you want to make sure that it's uh, as vertical as possible, and consistently as vertical between those different measurements. So you can, like I said, rotate it that way, but I would ensure you don't go like this way.
Yeah.
That makes sense.
Okay, definitely. So always point it directly at the zenith, which I
Yep.
love. It's the tippity top of the sky.
Yep.
I don't know. There's something about the zenith that I love, and it's so magical.
Hmm.
Okay, there's some questions here about kind of just Bortle 1 skies. They seem to be an enigma. Um, are they real? Do they exist? Because some people are saying like, Bortle 1 doesn't exist only if you're in a place that's really dark and there's no air glow. But I've definitely heard of Bortle ones as, there's a couple left in the US, or you can see them if you're in the middle of the Pacific Ocean. And like, what is your quality of finding the SQM equivalent to a Bortle 1? Do they exist? Tell us all about them.
Oh my gosh. That's a good question. It sounds like a lot of people here are very knowledgeable about them. So, my understanding is the Bortle classes were initially developed to help astronomers like classify their skies. So it was sort of based on, it wasn't like a direct quantification of like how dark the sky is.
Mm-hmm.
And that the adding the sky quality meter readings to them sort of came second in terms of our like what the Bortle class was used for. That's again my understanding from reading about them. Um, I don't know. We throw out anything that's higher than a 23 and that number, because that's considered
Yeah,
unrealistic.
I heard even over 22 is like really not accurate.
Yeah, yeah.
So,
I apologize, I lost the string here. Yeah. Um, I mean, you never know. And there might be something in the device that's causing it to read high or low. And so we throw out something. Yes, they are an endangered species. I agree. So we want to be cautious that, we're not throwing out data that's could be potentially just due to a device correction that needs to be made, right? We can understand that later. So that's why I throw out greater than 23, even though 23 is, yeah.
yeah, I've never seen it. Yeah, so this is a question from me because I have the host privilege here. Why do you throw out the first reading?
So it has to do with the device like heating up and the temperature within it impacting the device or impacting the reading.
Okay,
Yeah.
that makes sense. So you're just trying to like get her warmed up and ready
Yep.
to go. Okay. Um, cool. I mean, I feel like we got to most of these questions here. People are answering them themselves in the chat.
Great.
SQMs are
Awesome.
sensitive to Aurora, I would assume.
Yeah.
So very much so.
And airglow. There have been some interesting things people have done with even airglow and like from wildfires too. You can see that in the data,
Oh,
unfortunately.
totally. Yeah. Let's see, are there any questions on Facebook? We are streaming to Facebook, nothing on Facebook. So, if we didn't get to your questions today, Caitlin was very kind to share her email in the chat. So you can reach out to her via email. You can also reach out to her on the Advocates Slack. And the slides, Caitlin, you will post them immediately onto the Starry Skies North website,
I think
right?
so. Within a couple of days, I'll have
Okay,
our
in a couple
website
days.
posted.
Yeah. Yeah. Do you have any closing words you'd like to share with the team today, Caitlin? And I do just want to thank you again for your time. This was an incredible presentation, super inspiring. A lot of people have mentioned they're going to kind of turn around and start measuring. You've inspired me as well. I'm going to put Globe at Night into my calendar because I always forget when it is. So yeah, do you have recommendations for how to remember when it is? And any other closing words you have for the team today?
Yeah, Chris, thank you. I'm honored to be here. And yeah, I'm glad to hear that I empowered some of you to go out and start taking data.
Cool. Incredibly brave to be a dark sky advocate and to be out here advocating for a better world. And it's not an easy thing to do. So I really take a lot of inspiration from all of you and a lot of hope for the future because of all of you here today. So thank you so much. And we'll see you back here soon.